This is lesson 1 through our virtual classroom sessions. We are starting chapter 2, the derivative of the function. So far we have determined or defined this limit. I'm sure you are familiar with that. That is the instantaneous rate of change of any function f of x at any point. The instantaneous rate of change, again, could be defined as the slope of the tangent to that curve, f of x, to the curve of f of x at any point x. So it is the, let's say, technically the vertical change divided by the horizontal change. So y over x, delta y by delta x. Now, as we are familiar with this instantaneous rate of change, I'm sure you're also familiar that it is not an easy task to find the derivative or to find the instantaneous rate of change using this formula, especially with some complicated functions like cubic root functions or functions that have like higher exponents, probably an exponent to the power of 5 or 6. So you cannot expand exponents to the power of 5 or 6 and so on. Hence came the derivative. So technically the derivative is going to be formulas to find the instantaneous rate of change without resolving to this. So that is its basic idea. However, the derivative is a solution to help us avoid doing this, to finding the instantaneous rate of change. However, when you're asked to find the derivative, always remember that the derivative function is the instantaneous rate of change at a given point. That is the derivative function. Now, derivative function is a new function. We call it f prime of x. So it is called f prime of x. That's how we denote it. So if the function is f of x, the derivative of f of x is f prime of x. What if the function was g of x? Then the derivative is g prime of x, and so on. How do we find the derivative? It is exactly finding the instantaneous rate of change of that function at a given point or at a general point x. In the first section here, we're going to be using what we call the first principle, where we're going to define the derivative using its definition. In the next section, we will start learning the formulas. And the formulas would be for each function. For example, in the polynomial function, we would have a formula. If the function was a cubic root, we have a formula. If the function was an exponential, we have a formula, and so on. So in this first section, we're going to first start by using this definition to find the derivative. So now we're going to define differentiability. So a function y of x, y equals f of x, is called differentiable at x if f prime, which is the derivative, which is the rate of change, the instantaneous rate of change, exists. In other words, if we can find this limit. Remember, sometimes we cannot find the limit. We can say the limit does not exist, so DNE. So if we were able to find this general form, then I can say that this function f of x is differentiable. In other words, we can find its derivative. We can find its instantaneous rate of change. So a function of x is differentiable over an open interval ab if the function is differentiable at every number in that interval. Now, this is a vague statement, but this statement here means that we are finding the general instantaneous rate of change. So finding the instantaneous rate of change at x, not at a point 1 or 2 or 3. That is technically it. So interpretations of the derivative, it is the slope of the tangent, it is the instantaneous rate of change, as we said. So if the function is at a point A, then we say it's f prime of A. If we're finding it in general, then it is f prime of x. How do we denote, or how do we notate a function, a derivative function? We have two types of notations, and both of them are of equal importance. For convenience reasons, we use this notation. So it is like, if y equals f of x is the function, then y prime is the derivative, equals f prime of x. This is called Lagrange notation. So that's how we read it: y prime or f prime at x, or of x. Or we have Leibniz notation, which is dy by dx. Remember that difference on the y divided by the difference on the x. This is technically the slope, y minus y over x minus x. So the vertical difference or displacement divided by the horizontal displacement, that is dy by dx, or d of f of x by dx. Remember, y is the same as f of x. That's Leibniz notation. So we will be using this or that. So whenever you see this or that, then they are asking you to find the derivative. And here just I'm saying, like, we read it like dy by dx, dy by dx. If we're finding the derivative at a point, so we read it f prime at a, or dy by dx at x equals a. So if we're finding it at 5 or 6 or 7. So this is our first section here. First, principles. Differentiation is the process to find the derivative function for a given function. Now, if you read this term, differentiation, it means that we are finding the first derivative. We're finding the derivative of a function. So finding the instantaneous rate of change or calculating the derivative is called a process of differentiation. First principles is using this definition. Remember, questions later would be asking you, find the derivative or differentiate using first principles, or find the derivative using the formulas. So let's keep this in mind. That's the first example. Use the first principles to differentiate each function. That's my function here. So to find the derivative, I need to find the instantaneous rate of change at any general point x. So first we have to find f of x plus h. So we substitute x plus h for each x. So this is this. It's 2 times x, now it is 2 times x plus h. Minus x cubed, now it is minus x plus h cubed, because we're putting x plus h for x. Then we apply the limit, but now we call it f prime of x. So instead of saying IROC, or instantaneous rate of change, or slope of the tangent, we will call it f prime of x, which is limit as h tends to 0, f of x plus h minus f of x over h. So this is f of x plus h. This is f of x itself. That's f of x itself. Remember, it is always this minus that. F of x plus h minus f of x. So you should have two things here. 1 minus 2. Now, for the sake of simplicity now, I subtracted this minus that and this minus that. I grouped them. I grouped this. Now you could do it in any way you want. Anyway, is good. Now I did it here, that's the easiest way I could find. So I grouped this and that, so it is 2 into x plus 2h minus 2x, and then I grouped the cubes together, this cube minus that cube, so this minus that here. And remember, this is the definition of the limit, so we can split the, if you're finding the limit of the difference, so we can split the limit. So now limit as h tends to 0 of 2. Now I believe you should know where did this 2 come from, because it's going to be 2x minus x would cancel, then I would have 2h here, right? 2h, h and h would cancel, so it's only 2, minus this limit, this. Now I would show you how we did we simplify this in class using I have a small whiteboard, so we did that. We basically applied the a cube minus b cubed, a cube minus b cubed, but I will show you how did we do that in class. I have a small whiteboard. Then h cancels with h, then we got that 2 minus 3x squared. Then we say therefore f prime of x is 2 minus 3x squared. Now we calculated the derivative of this function using first principles, and we got that. So this is dy by dx, or f prime at x, or f prime of x, and that is the answer. Here we have another example. We're going to discuss it in class. Again, radical example. We would discuss it in class also. That's a solution. Now, finally, this is like non-differentiability. Again, we would say a function is non-differentiable if the limit does not exist. Remember, sometimes the limit does not exist, so we say that the function is not differentiable. Those are two important notes. If a function f is not continuous at x equals a, then the function is not differentiable. So if it's not continuous, there is a gap, there is a jump, there is a break. Remember the 3 types of continuities. There is a removable point. Then we would say the function is not differentiable. If a function is continuous, then the function may be or may be not differentiable. So continuity does not mean differentiability, but not continuous, that is for sure not differentiable. So that's the derivative, that's the curve that I was talking about. At any point here, the derivative is finding the slope of that tangent. That would be it for this video. Before we finish, I'm gonna just discuss this example with you. So it says find numbers x where the function is not differentiable and explain why. So I would see that the function is not continuous. So definitely it's not differentiable here at 4. For example, I see there's an infinite discontinuity here, right, at -6. So the function is definitely not continuous at definite 6. I see, for example, at -4, it is continuous, and I can find a tangent, right? There's a slope of a tangent here. So I would say most likely, or 99.9%, I can find a derivative here because I can find the limit, and so on. Now we have the solution. We're going to discuss this more in classroom. I don't want this video to be so long. And that would be the end of this video. I would be seeing you tomorrow at 6. Please come prepared, watch this video again and again, so we would start our classroom when with you having something in your, let's say, background. And I hope to see you soon. Thank you.